This will be about as hard as it gets, okay? So,
Wait, you keep saying that. You keep saying this is as hard as it gets.
for this,
It just keeps getting harder.
for this particular little piece. Yeah. We just keep building. It gets harder because we keep building on what we've done.
So this is not the hardest it gets.
Well, this is the hardest of the first 3 lessons.
So it will be harder.
It's the hardest.
4.6 is a little bit tricky. 4.6, 4.7.
What's 4.6?
You will find out very soon. You just live your life in the moment. Don't worry about what's coming tomorrow. Just live right now.
Okay, so that test we have on Wednesday, we don't have to study for it.
Well, you don't. Yeah. Live in the future sometimes. Okay. What is going on? Oh, okay. So here, you guys already know this, okay? So that I was looking around for what we're talking about here, but we're just talking about the base graph again. Okay. So direction of opening is up. The vertex is 0, 0. Like if I were to plot y equals x squared, remember? 1, 1, 2, 4. Negative 1, 1, and negative 2, 4. Okay, that's just a base graph. That's that guy. And then the optimal value, it opens up, so there's going to be a minimum at 0. When x equals 0. Okay. Axis of symmetry is at x equals 0. Y-intercept is at 0, 0. This is a boring one, but it's called the parent function for a reason. They're all boring. They're all the same all the time.
So they're all 0, 0.
Well, for the parabola, yeah. For this. It's only when we start throwing things into the equation that it starts to move around and get more interesting. Then things start to change. But the base one here is just, it's all is what it is. It's what you see there. Okay? So, this is the a value. We're going to, not a value, like the coefficient a. Okay? And then we're going to define a as a control and then be able to discuss its role in affecting the y values. Okay? Same thing here as earlier. You can always do this. As I was saying this, Lucas asked why can't I use my calculator all the time? What will happen when you guys take the 3U? The tests get written in like 2 parts. You get one part handed to you. You write it, but they won't let you use a calculator. Right? That's to force you to not do this. You're not allowed to use a calculator for these. Okay? That's how they force it. So it's they do it with good intentions because this is the easier way to do it and it's faster. Okay? You don't want to sit here and type this in every time. Okay? I'm doing it just to show you guys why and what's actually physically happening. Okay? So if I plug in these values into x, right? Remember, I'm going to plot the original again. Okay. I'm going to plug in the points, and all I'm going to get here is negative 2 squared times 2. Negative 2 squared is 4, times 2 will be 8. Okay, negative 1 squared will be 1, times 2 will be 2. 0 squared is 0, times 2 is 0. 1 squared is 1, times 2 is 2, and 2 squared times 2 is 8. So, you're going to plot those points. Negative 2, 8. Negative 1, 2. 0, 0. 1, 2. And 8. Okay? What do you notice? What is different about the red graph relative to the black one?
Is
Coco?
it on -1 or is it on 0?
It's on 0. Sorry. I just drew it a little bit big, sorry. What's different? Visually, right off the bat, what's different about it? I think the red one looks skinnier, right? Relative to the black one. Right? It got skinnier because what did we do? We grabbed the top of the black one here, right? And I pulled on it. I pulled on it and it got skinnier. How hard did I pull? By a factor of 2. So you should expect to see here, right? This point here, the red point, sorry, I'm not going to generalize. All of the red points are twice as tall as their counterpart black points, right? You see that? This one went from 4 to 8, right? So what's this doing? Stretching. Okay. If I go to the next question here, we could probably take a nice guess as to what's going to happen. I'm going to plot the points again. The base graph points. Okay. What am I going to do here? If this side here grew by a factor of 2, what is this side going to do? There's no tricks. What is that? You guys are killing me. What happens? Cut it in half. Just cut every point right in half. Every one of them. Half. Half. 0 times a half is a half, or 0. There's a half. There's 2. What happened to the graph? Got twice as wide because I pushed on the top of the black one. I pushed on it by a factor of 2. So I compressed it, right? Compressed it, it got twice as wide, if you will. Not twice as wide. We just cut the values in half. Okay, we were at 4, we cut it down to 2. Do we have any issues? Nobody's saying anything. I know Red is not here. I was just thinking that. That's funny. He's going to watch this now. You see? They get caught up.
Okay, so I guess I have a question.
Yes?
So before it was 2 and it made it skinnier, but now it's making it like bigger. Why is it not making it like skinnier by half? Well, I mean, like I get it because I see the points, but why are you taking half away but adding some?
What do you mean by adding half?
Or actually, I guess it doesn't make sense at all. No, I don't know. I'm just.
I would.
They're both positive numbers. Why does it have?
Oh, it's like if I did the y values for this, right? If I did the table, this is fine. Like I don't mind doing this. I just gotta show you guys. So if I plug these in here, what happens? I'm gonna plug in -2 for x again, right? That's gonna be 4. 4 times 1/2 is 2. So I plot that point. All you're doing is plotting points, right? But this is just a faster way of doing it.
Okay, yeah, I mean, yeah.
And then you plug in 1, half of 1 is 0.5. Half of 0 is 0, 0.5, and 2. Okay? We prefer not to see this. Okay? Because the functions, if I gave you a function like you're not going to sit there and type in the values. You want to know what that looks like, and then I'm going to move it around using the exact same principles I just showed you over the course of today. You can do the exact same thing. It's just a different picture that you're moving around. That's grade 11. Okay? That's why we're doing this.
So we're not gonna see y equals 1 over x,
No,
right?
you won't see that. Unless I prank you. What's it?
For the graph, can you say more and less speed?
Say that again?
For the graph, can you say more or less speed instead of saying wider?
Yeah, they are. The slope's different. Yeah, you'll do that. That's more like the instantaneous rate of change gets increasingly bigger. That's a grade 12 word. That's where you're headed. You don't have to worry about that. You just say, I'm going to cut it in half. All the values are just going to get cut in half. So you're going to either vertically stretch it or you're going to compress it. Okay, if it gets fatter, you compressed it. If it gets taller, or you get skinnier, right? If you stretch it. Okay? Now, here's the last one. Again, you can do this in 2 stages here. I'm going to erase this because it's just distracting. Okay? We already know what the graph looks like for this one. Here's the base graph. We'll do it. I'll draw it again. On the test, I'm going to ask you to plot the base graph. It's going to be worth marks. So you guys may as well draw it because I think it's important. Just the whole practice of drawing the base graph is good. Okay, we already know what y equals 2 to the x looks like. We did it in the first one. Or 2x squared, I mean, sorry. It's twice as tall, right? So we're going to go up to the 8, up to the 8, and up to the 2. What is the difference between this question and the other one? So what's the difference between A and C is my question. There's a negative. What does the negative do? Or not what it does. What has it meant to this point? Like if you saw a negative out front as the A value, what did you tell me about the parabola? It opens downwards. So what do you think the negative controls? The direction of opening through a transformation, a particular transformation, which we call a reflection. It's a reflection in the x-axis. So you're reflecting over top of the x-axis, and now it's going to point downwards, right? So to do the reflection, I guess this could be like, this could be a point of stumbling for some people. Maybe, not after I show you, hopefully, but. Okay, so what you're going to do is you're going to reflect in that green line. So to do that, you're going to count the vertical distance of each of these points from the green line. So we'll start with the 0 because the 0 is right on it. It doesn't change, right? But this one here is 2 away from the green line. So I'm going to go 2 downwards, 1, 2. Same thing with this one, 1, 2. This one here is 8 away. So I'm going to count 8 away. 1, 2, 3, 4, 5, 6, 7, 8. Same thing on the other side. Okay. Do we have any issues with that? Okay. individually as like isolated skills, you guys shouldn't have too much of an issue. It's keeping track of everything when I throw it at you like in vertex form. That's why I write it like that. A, H, and K. Those are the three things that you need to know. They all do different things. K is the vertical movement, H is horizontal, and A is the vertical stretch or compression. If A is negative, you reflect. That's it. There's three rules. That's it. Okay? Okay, so a little down here in the summary. If A is greater than 1, the relationship has to be vertically stretched. This is a fancy way of saying a fraction okay? Does anybody have any issues? Coco?
Okay, so vertically reflective, is that just like over across the y-axis?
Over the x-axis.
But you wrote vertically reflected
Yeah,
for the second one.
Oh, sorry. I was ahead of myself. Sorry. Thank you. Vertically stretched.
But that's the same.
Or
as
sorry.
first.
Just one second. Let me. You guys have got me all in a fluster now. Is that better?
Yeah.
Okay. At least you're not hostile today, Justice. Not yelling at me. That's good for a Monday.
I don't do anything.
Okay. Do we have any questions? Okay. I'm gonna have to dig up some questions for you.